Have you been looking for some tools to help you with your Terraform? Hi, my name is Jason, and Olaf and I will be talking about some tools that could help you out. In the security realm, we have terrascan, and it's by Tenable. And what it does is it'll run a static code analysis based on your local Terraform code. So before you even do a deployment, it can run some scans and say, for example, it's showing here that it has you need to enable S3 bucket versioning. So this kind of catches it before you even do a deployment. It's kind of nice just to kind of prove out your code. But what if you have already code like, or what if you already have infrastructure already out into the different environments? Then you could use cloudsploit. Cloudsploit will you can set it up to look at your subscriptions and then does the same thing. So it kind of looks at like what kind of networking you have, what kind of versioning you have, follows the different policies. You can have it set to look at like CIS standards or things of that nature. It's kind of nice because you can give like a CSV report to a security team. That's what I've had to do a lot more of is provide a report to the security team of what the vulnerabilities are so that I can turn around and go fix them.
Now, in both cloudsploit and the Tenable product, are these things that interface directly with Terraform, or do they interface directly with your target?
Well, with terrascan, it interfaces with your Terraform.
Okay.
So it's a static code, so it'll run like before you even run anything. Cloudsploit,
Okay.
you'll run it against your subscription or account. So it actually runs against what's actually active in the cloud.
And cloudsploit is by Aqua, and the tool that I use on a fairly regular basis is also by Aqua, and it's tfsec. And tfsec actually probably ties into cloudsploit. I don't actually know how tightly integrated they are. It may just be like backend signatures that they share, but effectively tfsec, and I can show a demo if this is a good point to do that. It's relatively simple for some of its basic capabilities, but I guess just to give a little bit of a preliminary, tfsec made by Aqua. Aqua is a company that many of you have probably heard of, just like Tenable, but Aqua is a pretty heavy security platform working specifically on like the DevOps supply chain. So it's like a supply chain scanning tool for code. But it's actually a lot more than that. And I think it's pretty cool that Terraform users get a little piece of that for their use, and it's open source. And I know that Aqua puts a lot of emphasis on the open source community, and this isn't sponsored, by the way, but they have a whole division of team. They have dedicated people that are working on open source products and tools like tfsec, like cloudsploit. They have a couple others that I can't think of the name right off. But basically, on my screen here, I am just in a directory here. And so I might go into, let's see, like this network security directory. And so this directory has a bunch of Terraform files within it. And so then I would run tfsec, and tfsec run by itself will just run its full battery of tests. So if I just execute that, no parameters or anything, it comes back and tells you that there are potential problems detected, and it will even show you the severity of those things. And so you can kind of walk back through and see that all of these appear to be lows, and they are potential lows because they relate to these secrets. So it kind of depends on what you have stored in these secrets. So it just spits out these tests, but if you give it something a little bit meatier, I guess, to chew on, then it can actually give you a lot more interesting information out of that. So for instance, I might say, what is it? Alders, I think. Close. Force alders. So if I it's recursive effectively at this point. So I can have it go through all my directories. There's tons of them. And so now you can see that there are criticals, highs, mediums, and lows, all different categories. And you can also have it exclude certain categories, which is kind of nice. A lot of these have to do with secret expiry. So for instance, if I did this and then I wanted to exclude some key vault expiry notices, we'll run it back through. So right now it's 30 and 66, 30 passed, 66. So now you can see there are 30 passed, 22 ignored, and then 44 potential problems. So that's just kind of the way that it divides those up. And this is, you were saying cloudsploit checks against your cloud backend. And so I feel like they must tie into the same signatures, because these, there's a whole set of checks that it does for, in this case, it's Azure, but they also have a ton of checks for AWS. They have some for Google, a bunch of others as well.
So is this one subscription based? Like you have a
this is not, no, I'm sorry, what do you mean by, do you mean purchase, or do you like entitlement?
No, like, so like cloudsploit, you can configure it to talk to your Azure subscription.
Right. Cloudsploit runs continually, right? Or every time you execute it anyway in the community version. This one runs against your scan code. So it is a static code scanner, but it's looking at what your code's going to do to the cloud and whether or not that would pose any issues based on what the cloud security posture is. Okay. So for instance, in some of their checks, it'll be like storage accounts are allowing public access, and it'll raise that as a critical error, right? Which is just based on what the cloud provider might assume as well. You can also, so we're showing like this, the last thing I can show on here, but you can also break this down. So right now it shows you all of the severities, but you can also just lock it down to maybe high. And then it'll do the same scan, and it will drop a bunch of those out, and you'll just see the highs and the critics. So minimum is high, and then it'll also show you the criticals. So you can just shorten that list down to things that you need to focus on. So pretty handy. But yeah, I like the Aqua tool a lot as well. I haven't used the other one, so I might have to give that a try and see how it compares. Because what I noticed about Aqua is that they have support for Azure, and it looks pretty good. But then if you look at all of the checks for AWS, it's massive. So what I don't know is if there are truly fewer checks for Azure as a cloud provider, or if it's just sort of the perspective, like there's a lot more collapsible categories, if that makes sense. Like an Azure storage account comprises, I don't know, 15 different checks, whereas in Amazon, it may be broken out more specifically, and you have different types of S3 checks sort of at the parent level.
Right. That actually makes sense from the AWS perspective. They're much more granular, which you can do. So what if you need to have different versions of Terraform on your machine? Suppose, back in the day, be like a year or two ago, you had to you had version 13, you upgrade from 12 to 13, and then you need the other projects you have 15, and then they have, you got some projects on 1.0. That's where tfenv comes into play. So you would do this, you can use this tool on Mac, and I think there's some Windows stuff now, but instead of downloading Terraform like you traditionally would, you would use the tfenv application, and it allows you to download specific versions of Terraform. So if you were locked into a certain version for pick a reason, you could move to that version, make your changes that you need to make, and then switch back to 1.0 as a matter of just a single command. We had that problem because, especially since the upgrade paths were kind of rough between version 13 and 1, you're like, okay, I don't have time to fix this right now, so I just drop down to that version of Terraform you have locally.
And is that basically such that you you use tfenv to cite what version, or can you also say like I want the latest 1.0 version, and then it just grabs the latest in that branch?
You had to cite specific ones, at
Okay.
least when I was doing it. So
Yeah.
if I was like, oh, it's like I need to probably upgrade to the newest version. Let me tf install 1.2.5 or
Yeah.
whatever.
Yeah.
So it was more of a manual configuration, but I feel like it's going to become less important theoretically since 1.0 is a little bit more backwards compatible. Um, Before 1.0, everything was like between major versions, it was significant. So you had to make all sorts of changes to upgrade.
Yeah, and I managed this a different way, just manually. Frankly, I would download a version, and as that version became outdated, and I wanted to try a new version, initially what I would do is I'd download the new version and I'd rename it to like TF10, right? TF
Mhm.
1.0. And then if I needed to use the 1.0 features, then I could try out using that as my binary. And then eventually I would flip that so that like my old one would be like TF1415, and my new one would just be Terraform. And that way I'm changing kind of my default nature as my default the new one or default the old one. And that worked okay. The only problem I would say that exists with that is I did have to run terraform-v frequently because I forget which version I was now calling primary.
Yeah, I could see that.
Yeah.
The last tool that I have is terratest by Grunt, and it provides end-to-end testing for Terraform modules using the Go language. I did some experimenting because I had heard about this and I haven't actually run this in a project. It was nifty because it allowed me to test out my module and it built out my infrastructure, and then it turns around and destroys it, but it's looking for the output. So you can say, hello world, which is the direction, say, and then if you have that in your output, then it's like, oh, look, that worked. Your test succeeded for unit tests. And it seemed really good for modules, especially since, as you're building things out, it'd be nice to test it out without like remembering I got to go destroy my test infrastructure and things like that. I feel that
Because that
we've
infrastructure costs money, right?
it does. I feel that this would be a good, uh, more in-depth video. So we'll probably make another video just on how terratest works in the near future.
Yeah, I can see that of being of some value, real value. Frankly, I mean, there's really no question about it. I think the one of the plans that I had built once upon a time was having a separate environment that would not exactly replicate everything else, but that it was just a build target. And so the idea was that you take all of your infrastructure as code that builds the foundation or the landing zone, and you apply that to this clean slate environment every morning. And so all automated applies, network and security and possibly even like things like the express route setups, although that's a little bit more detailed. And then other teams can build against that environment, and they'll see right away whether or not the infrastructure changes that we are now deploying are causing any impacts to their downstream application deployments or downstream infrastructure deployments. So there was a lot of value in that. And then at the end of the day, it would destroy all of that infrastructure just to start over the next day. And that way, we always had sort of this demarcation point in time where you could say environment is new as of this date, and then you could cite versions and things that may have applied. Many times there were no changes. And you would just have this running tally as to it's a lot like the way Git works, where you have build test automation that shows whether or not you success. So we actually called it our CI environment, and it was an infrastructure CI test environment. And so I can see where terratest could actually be beneficial in automating some of those pieces, because I can tell you that destroying an entire environment at the end of the day, using Terraform is actually, for one, tedious, but for another, a little trial and error. Like, it doesn't always work. So having a tool that explicitly is designed around that might actually make it work better.
I agree, especially if you try to destroy VNets.
Yeah, I mean, it's all about the timing and yeah.
It's like, how many times do I have to run this destroy for you to go away?
Right, right. Another one that I use with some frequency is called terraform-docs, and I call it tfdocs, and that's only because I use tfsec, and that's super easy name for me to remember, and so I alias terraform-docs to tfdocs, just so that it's easier for me to get to. And terraform-docs works a little bit like tfsec insofar as that there's just kind of a simple way that you can run it and get some immediate results and output. But then there's always more that you can apply to that to customize it for your needs. So I'll start with actually start with the customization a little bit, because the basic run is pretty simple, but the customization effectively takes the basic run and any modifications that you pass to it and then makes them consistent for all executions of tfdocs. So in my case, I'm using .terraform-docs.yaml. So it's just a YAML configuration file. This is the standard file that it will use. So if I run tfdocs, whether and this is why I'm showing customization first. If I run tfdocs and it sees this in the root module, then it will use this as my configuration settings without me passing anything to it. So effectively, I'm changing the output results by the existence of this file. But you can see I've got just like a formatter entry, so I'm going to be using Markdown table format, and I have recursion turned on, which is a little interesting. You have to think about recursion in terms of relative execution. So if I have to think about where I'm running it from to tell it how to recurse. Just a little bit of nuance to that. But at any rate, if I'm in a directory and I don't really, this is kind of my root that has a lot of other, not exactly modules, but just like components that I might run. So then if I run tfdocs against, like, I'll run it against something a little bit more interesting. If I run tfdocs against this bootstrap directory, then you can see it actually it creates a README in the bootstrap directory, and then it also does the recursion against those modules. So it recognizes that from the bootstrap directory, it's up one directory and into modules, and then it creates README updates for all of those modules that are out there. And you'll also note that it says updated successfully, so it's not overwriting these, and that's in the configuration file, you see mode inject. That's the default mode, but you could also make it overwrite. And I choose inject because then it can actually just make changes to those, which is kind of nice in terms of source control. You can actually see the discrete changes that occur, and it helps you ferret out maybe undocumented changes or changes that just weren't documented fully. This could help you ferret it out. But what it creates, and I think that's probably the interesting part, what it creates are these handme readme files, which are already formatted nicely for something like a get readme. And so you can see over here, it shows us providers, modules, all the resources that are in use. But then it also shows you inputs and outputs. And if you remember from an older video where I talked about modules, transporting, what I referred to as like your procedural code into child modules. Same sort of concept here. I documented inputs and outputs inside my code so that it would more easily allow me to connect those pieces together. tfdocs or terraform-docs does the same sort of thing, where it will document all your inputs. And what's nice about it is that it actually reads your description and puts that into this. And there's all kinds of formatting changes that you can make to tfdocs. And you can even change the structure of this README in general. But I think this is really handy. Like it pulls in the value type, it pulls in the description, it even pulls in the defaults if you have those. So pretty handy there. And you saw that it created one for all of the modules. This is the one that it created for the directory that I pointed to. But if I then recurse into the modules, then we will see READMEs over there that work very much the same way. There's the module. This is Azure Key Vault module. And same way, it shows the inputs coming into that. And I didn't document these nearly as well, so they're just a little uglier. But nonetheless, it will show you everything that you've put into that. Incidentally, it'll also show you what perhaps you've been lack on and didn't document well in your code. And so then you can go ahead and get your code updated so that your READMEs are better read. One last thing that I'll point out about this is that there's there are template designs that you can apply to it. So I said you can modify the format and structure. You can do that all through the templates, but there's also headers and footers that it can pull. So if you have like disclaimer text or maybe you have license text, things like that, you can put it into your code consistently, and it requires it to be multi-line commented. It's got a particular structure that it wants. You tell it where that is, and then it will always pull that and add it to your READMEs as well. So it just structures really nice documents in the end. I thought it was pretty handy. Those are tools that I use routinely because of their utility value that they bring us.
Yeah, I could have used that on my last project. That is the end of what we've got. If you have any questions, please leave a comment in our video, and like and subscribe if you want more content like this.
All right, we'll see you next time.
Thanks, guys.